Welcome to Neal on Fire, the podcast where we explore the technologies, the science, and the strategies shaping the future of wildfire resilience. I'm Neal Spungen, and today we're diving into wildfire modeling, one of the most important tools for understanding wildfire risk. Today, my guest is Dr. Alexandra Syphard, a senior research scientist at the Conservation Biology Institute and director of science for the Global Wildfire Collective. Alexandria has authored over 120 research papers on wildfire and is widely recognized for her work on wildfire risk modeling and how ignition sources shape wildfire behavior risk in the wildland-urban interface. Alexandria, welcome to Neal on Fire. I'm excited to talk to you today.
Thanks, Neal. I'm happy to be here.
So many people hear the term wildfire modeling, but don't really know what that means. How would you explain the role of modeling in understanding wildfire risk?
I think I would start by discussing that wildfire in general is much more complicated than many people think it is. We use the word tightly coupled, meaning it involves interactions between people and ecological systems, and it plays out over a vast range of scales, from the seconds that it takes for a car to backfire and starting a fire to the decades it takes on a global scale for fires to change forests into shrublands or grasslands. And so you can imagine with all of this complexity that there are many different questions one might have about fires. Why did they occur? What are their impacts? What are their impacts to ecosystems or people? And so for all of these different scales and all of these different questions, we collectively as scientists have developed many different models to answer those questions. And models essentially are, by definition, simplifications of reality. So what they do in terms of fire, for example, is that they take the physical, the biological, the social processes that influences fire, and they put them into mathematical equations that enable us to answer questions we would not be able to answer otherwise. They can allow us to ask what if questions. So we can't actually change the future and then make a decision about how we want to shape it, but models allow us to see and to envision different futures under different, for example, management scenarios. And this is why they're so great for decision making, but they're also great for even generating questions, because sometimes they teach us things that we wouldn't expect and they give us surprises.
Great explanation, but I have a question for you. So you talked about the relationship between what happens in the natural world and what happens when we're talking about human development and the impact of wildfire. So I'm curious, because you're constantly looking at this, and of course so much of wildfire modeling is driven from concerns about the WUI, wildland-urban interface, because we're developing more and more into the WUI, places where we really shouldn't be building. But I'm curious, what are some of the common misconceptions that communities have about how development might influence wildfires?
Yeah, great question. I think there are a few misconceptions. One of them is sometimes that development is only something that is influenced, or that without considering all the different complicated ways that development itself shapes fire. So development, of course, you bring new housing into undeveloped areas. You're then bringing people, you're bringing ignitions, you're changing the vegetation in terms of what kind of vegetation it is. You're changing the arrangement of vegetation, and you're changing where firefighters are going to go when there's a fire. And so, of course, then all of those things change the fire, which in turn affects the development in question. So you can almost call it sort of a positive reinforcing relationship with development. The other thing is that a lot of folks, I think, get confused. Even scientists get confused that the way development is placed on a landscape, so the housing density, for example, the location, the pattern, it can have multiple different ways of interacting with fire, because it in and of itself is, placed within a context where there are certain conditions relative to fire, like weather conditions, wind quarters, the type of vegetation, the type of ecosystem. And in many cases, I'd say historically, I've done a lot of work looking at structure loss over time. Most structures are destroyed at low density housing patterns in areas that tend to be prone to fire. But that relationship can switch. And many of the fires we've seen recently, where we see like Los Angeles or Paradise in the Camp Fire, the Tubbs Fire, where all of a sudden the relationship becomes that once fire gets into a very dense urban setting, then all of a sudden it's the high density that's the risk, because then structures become the fuel themselves. You've got embers that are, especially in wind driven fires, that are transferring from one house to another. And so people like to say on the one hand, well, it's low density that's a problem, and other folks are saying it's high density. And the truth is that it's both. It just depends on the context and the fire and the setting behind it. A third misconception, which I'm not sure if this is still within the question, but I'm thinking of it now, is that a lot of folks, and I think this is important just in general thinking about fire, is that the things that homeowners can do to make a house safer, so defensible space, retrofitting your house, building up to code, all of these can, to different degrees, reduce the likelihood that your house will burn in a fire. But you and the Australians will often say this, there is no such thing as fireproof. You cannot guarantee that a house is going to withstand a fire. And I see, because I work with a lot of agencies, I see a lot of plans for development that argue that we should just put development anywhere. It doesn't really matter because we're going to do all of this work to fireproof our houses. And so this to me sounds the alarm bell, because it creates a false sense of security. And, it doesn't matter. There are still homes that do everything perfectly that are destroyed in fires.
So when I hear you talking about wildfire risk models, and I've looked at those models as well, oftentimes they involve so many different pieces of data to really develop a full model, and it can be complex to the average person. But when you net it out, what factors do you think are most important? If you had to just look at a handful of things that really drive outcomes in wildfire, what would they be?
Well, I hate to be the one that says it depends, because scientists always say that, but it really does, because it depends on the kind of fire model you're using. When people talk about fire models, most of them tend to think about fire behavior models. And those are those models that generally use topography, elevation, slope, they use fuel, they use weather to model how a single fire is likely to progress across a landscape once it's ignited. And in those kinds of fires, or those kinds of models, the model algorithm or the mathematical formula in the model is sensitive to the inputs, which would be, for example, those I just said, fuel, weather, topography. But if you are using an entirely different kind of model, if you are using a land use model coupled with a simulation model that looks at vegetation change over a long period of time, it might be sensitive to a whole other range of parameters. It might be sensitive to where the ignitions are likely to start near development. And different models, just simply by nature of the way they are mathematically created, have different sensitivities to different variables. So sometimes it isn't necessarily even when you go out on the landscape and you say, what is driving fires? You might come up with a ranking of all those things that are very important in affecting where fires go and what their impacts are. But in a model, sometimes the sensitivity is disproportionate relative to reality. And so a lot of modelers do what we call a sensitivity analysis. And that is a way of adjusting the parameters in the model in an incremental way that allows you to see how sensitive the outputs of your model, or the results or the conclusions of your model, are to changes in the parameter of the variable in the model. And if they're very sensitive, then you need to be very careful about how you put those data into the model and interpreting the model in light of them. And a lot of times in decision making, because, for example, you might have a great sensitivity to temperature in the soil, for example, then, people might need to understand when they're interpreting the model what you did to create that relationship between soil temperature and plant growth. So it's So I'm not giving you a straightforward answer, but these are just things to consider when one is about to undertake modeling, or is when one is a decision maker and they're trying to understand, well, what is it that went into this model and what are the most important variables? And of course, I'm not even getting into data quality, which is a whole other which is
Well, I'm so glad you didn't answer the question with just a straight answer. Everything you shared was really helpful in hearing, but I'm also curious about how the models account for the ignition source. Like I've heard that human caused wildfires are 80 to 90% of the problem, and that might be intentional, that might be unintentional cause fires, but how does that get factored in, the actual ignition source or versus lightning or something that might not be human related?
great question. I think a lot of times ignitions are overlooked in a lot of the models and also in a lot of the solutions to wildfire problems. And something to consider is that there are models that just simply look at ignitions in and of themselves. So while you're correct that ignitions seem to be very random and unpredictable, and in any given event, an ignition is unpredictable. But when you start to aggregate them over time, you start to learn that different human sources of ignitions, as well as lightning, start to have their own characteristics in where they tend to be located, when they tend to occur throughout a year, and why they're occurring. And further analysis can then address questions like, well, which are the ones that are resulting in the biggest consequences? So, for example, our research, and this is sort of an aside, is that I think in all modeling, it's equally important to be always be doing empirical research beside your models, because understanding the system and using historical data from real fires is critical for understanding the modeling of those fires. So I've done a lot of work empirically trying to understand ignitions, where they occur, why they occur. And, so some of the ignitions, it might be equipment, might cause 90% of the fires, but those 90% of the fires aren't the 10% that cause the biggest impacts. So within each region, it's important to sort of do your own analysis first to figure out which are the most important sources, where are they, when are they? And then you can create a map or a model just on those ignitions, but then you can also use that information to input to other models. So, for example, the fire behavior models I was talking about, many of them will model the behavior of a single fire, and they'll do 1,000 different fires, all starting at a different place on the landscape. And historically, most of those types of models have just used random ignition locations. They've just said, imagine a fire starts anywhere on the landscape and see how it spreads. But we know that ignition locations actually are not random at all. They're very geographically patterned. So you can create a probabilistic map showing you the relative likelihood an ignition will start at a given place. And you can feed that into your model so that then when you're looking at where a fire will spread, you're starting that fire from areas where it's most likely to start.
So, given that wildfire modeling includes things like vegetation and climate and so forth, some things that are perhaps more that are static and some things that are evolving. Once you do a wildfire model, how often do you suggest updating it to address changes in vegetation or other factors?
Yeah. That again also depends on the model and what time frame you're looking at. So, for example, if you're a firefighter and you have a technician who's running fire behavior to understand actual conditions happening at the moment the fire is occurring, you want those conditions to be accurate. You want to know where the weather is, you want to know what the vegetation is. So you need to update that maybe once a season. If you're doing models that are looking at how are forests going to change and affect carbon balance in the next 50 years, a lot of those processes that you're modeling happen over longer periods of time. So, in many models that I use, for example, we might be looking at where are large fires most likely to occur on a landscape in the next 30 years. And if it's over a large enough landscape, we might assume that development stays where it is because incremental changes in development aren't enough to significantly alter the outcome or the output of the model. So the model is sensitive to changes based on what the question or objective of the model is and what kind of input data you're giving the model. Depending on, for example, if you are a utility company and you're trying to look at the likelihood that an ignition from one of your lines is going to start a fire that has a consequence, you might update once a year, once every 5 years. So, so it's really depends on, in modeling, we often use the term fit for purpose, which is basically what is the objective? And then you look from there, how do you build the model that includes as much detail as needed, but not more?
With so many wildfire technology devices coming out and remote sensing and drones and everything else, what role do you think wildfire modeling plays in kind of marrying up potential detection and mitigation technologies with the best application of them?
hmm Yeah, I mean, um, the new technology is happening quickly. I think that one of the best examples is remote sensing. There's, for example, a program coming out called FireSat, which is supposed to provide very real time and accurate location of where fires are going to be located. So this changes the modeling landscape if you're trying to, and I think of it again a lot in terms of empirical work. So if I want to know how fires are playing out in the Amazon and you can't walk to see where those fires are and you don't have enough spatial precision to know how frequently especially small fires are happening, this allows you to create data to input into models, but also to just simply understand by looking at historical observations, you get a better and more accurate sense of what the relationships are between the things that are driving fires and the consequences that those fires are having. So we also, another word, expression we use in modeling a lot is garbage in, garbage out. So the quality of the data you put into your model is directly related to the quality of output you get from that model.
So, very good point. With that in mind, they've got so much data going into these models that I think for someone on the receiving end who's looking at a report or trying to interpret this, it could be overwhelming. They're just looking for a decision support tool, something that says, here's what you can do to help mitigate fire risk. But how do you balance that, keeping the scientific rigor, but yet kind of being able to speak to the kind of audience that needs much more, I would say, straightforward information on which to base wildfire decisions?
Yeah, I think this is starting to approach the topic of uncertainty because all models are wrong, but some are useful. A lot of people, unless you have some kind of training in modeling, you don't know how much you can trust a model. And this is something that we as modelers deal with all the time. Science communication is really important. And sometimes it's hard it's hard for two reasons. One is politicians don't think they can trust the rigors of a model, and so therefore they're not likely to use them. So, they don't necessarily understand that we can't predict a fire's going to happen on Joe's yard in 1921 on May 10th. You know, we can give you the relative ranking among different scenarios. So sometimes you need to be able to understand, what is the biggest effect where, what is the relative difference between these two management decisions. And if you don't understand anything about modeling, I can understand why you wouldn't trust that. But on the other hand, some people take models way too literally, and they do believe that, if a model gives a map that suggests the fire is going to happen at Joe's on May 10th, they actually believe that. So I think what it comes down to is the important role of communicators and educators in translating how models can be used, what are they useful for, and how do you use them to make informed decisions. So it's, and there, quite frankly, there are also a lot of really bad models out there. And I think it's also important that we train the next generation of modelers to be responsible because some of these models look deceptively simple to use. They hand you this beautiful looking interface and you click a few buttons and voila, you've got a map of fires. And, just because it looks nice doesn't necessarily mean that it's correct.
So, given that, I mean, how many wildfire models do you think exist out there? Of that, I mean, it's a big number, obviously, but of that, are there two or three or four that you kind of count on that you think are the most accurate for any given situation that you use on a day in day out basis?
It's interesting that you should ask that. I just completed a small assignment for the California Department of Insurance because they are embarking on creating the first ever public wildfire catastrophe model. And I just so happened to mention to them that there are literally thousands and thousands of different fire models out there. So they called me on it and they said, well, can you give me a taxonomy of models? And so I did. And in that process, which was very, very not exhaustive because of the sheer number of models that are out there, I came up with my own taxonomy that had 10 different families of models. And within each of those families, I then broke them out into further categories, which then could be broken out into further categories. So this is a way of demonstrating that there are tons of models out there. How do you know which one you can rely on? Sometimes, and I hate to say it, sometimes as an experienced modeler, I will look at who's actually doing the work because I think that, especially for something like wildfire, which involves so much ecology, at the same time, it involves so much social sciences, involves all of these different disciplines, that somebody walking in who's just a computer engineer or programmer who doesn't have, sort of like a humble spirit to understand the subject matter, that raises alarm bells for me. So I think one is just simply reviewing the models. The peer review process in science, it still works. It's a good thing. People will publish a paper on a model. It goes out to experienced scientists who then review whether the model is actually doing what it says it does. And then knowing who's running the model for what purpose.
Reminds me of a book that came out a long time ago called How to Lie with Statistics. And it seems like whoever is coming up with a model might, in fact, have a bit of a bias toward a given outcome. And I hear what you're saying that you have to really vet the model and make sure that it's consistent with what you're looking for and that there's not any inherent bias in it. Do you ever see a point in time where we'll kind of get to a place where there will be a standard or, perhaps a couple of models out there, depending on what the environment is that's being addressed, so that we kind of eliminate this wild west of models and there's, here's the standard model. And this addresses everything you need.
To be honest, I hope not. And I say that because there is a desire for, and it's kind of a seductive draw to have something that is uniform and standardized and it fits all scenarios and everybody can use it and you use a consistent data source so your results are generalizable. But the problem with fire is that it's just messy. Fire has different regimes, meaning different ecosystems have different relationships with the drivers of fire and the consequences of fire. The behavior of fire and those processes that influence it change over time. This is a word we call non-stationary. So that means that any relationship does not remain the same from place to place, and it doesn't remain the same from time to time. And as I was mentioning before, fire modeling goes from the very seconds of combustion all the way out to decades across the world. And I also think that there are things that we haven't figured out yet how to model. So I think for the near term, one example, there are certain standards in fire modeling. For example, surface fire spread is generally a function of what we call the Rothermel equation. And there are also then crown fire models. And then there are also models that look at spotting, which is ember production. All of those have been sort of part of the fire modeling toolkit for decades. And they can be used effectively for certain purposes, but they have very well-known limitations, very well-known assumptions, and they cannot be used in a lot of different scenarios, many scenarios which we've never seen before. So as conditions continue to change, we start to see novel futures, novel relationships. The old approaches that we've used before are not sufficient to capture surprising behavior. So I think that at least for the foreseeable future, I hope to see innovation in fire models, and I hope to see a lot of different approaches to getting at the same question, because I think that ultimately, as long as there's communication, as long as science is published, and as long as disciplines are talking among each other, scientists and decision makers are talking together, I think those are the things that will enable us to be responsible in how we use our models and how those models are then used for making decisions.
So, talking about the models for use within the WUI, do you experience at all where there's land use conversations before a development happens that says, let's do some modeling, let's understand, hey, you know what, let's not build over by this canyon because that's where there's, increased fire risk. Does that come into play? Is there typically after the fact, the horse is already out of the barn, we've got, 1,000 homes that we need to protect, how are we going to do it? Or is it both?
Well, I wish it were the former. Back when I was doing my dissertation, which started in 1999, I was using a model that integrated land use change with vegetation change and fire, and how those would feed back with one another to create different trajectories. And in that model, I found that different types of land use could substantially affect fire outcomes. And back then, in the early 2000s, when I would mention land use planning or where to put the WUI or where to put new development, people would just tell me to just get out of there. We don't change land use decisions in the US. That is just not a feasible thing. And I tell you this story because the one thing that is heartening is that at least now, for example, you're asking me the question. And I hear people talking about it. I hear within the press, for example, after the LA fires, a lot of people called me up and they said, well, what about land use planning? What about where we place our homes? How do we rebuild? And that to me is encouraging because my decades of research have shown that the where you put your houses on the landscape make a really big difference, not only in how those fires will be impacted, but also, as I said earlier, how they will impact fires. However, I have actually personally heard that my empirical work, my looking at housing and where houses have been, structures have been destroyed and different types of land use planning patterns, that it made a difference. I've heard that those papers have been used to prevent certain developments in California from happening. I have yet to see any modeling application that says, here's where you should put your new development, and somebody actually putting their development accordingly. But we are doing it. I mean, we are doing that kind of modeling. We are increasingly, this is a term in the modeling community called model coupling. So certain models are designed to do certain things, and there are ways to couple them together so that, for example, if I run a land use change scenario, I look at urban growth under different policies, and that'll give me every 10 years a map of where new houses are going to be. I can then stop a fire and vegetation model at each time step and input the new development, and then have that influence the vegetation. Those types of models, they're not perfect yet because it involves a lot of assumptions and uncertainty. They're being developed, and we are starting to see through the models that where we put our houses in the future makes a difference. So that's a very long-winded way of answering by saying, I believe that in the future, those models will be very important for making decisions.
So, to the person who's out there saying, yeah, all this sounds great, but it sounds super complex. And now that you've told me that there's a whole taxonomy of models, I'm even more confused, right? And I want it simple. I want it easy. I just don't want to deal with this. But, people have to deal with wildfire modeling. So I'm curious to the person who isn't that familiar with wildfire modeling and they're just getting into this and trying to understand it. What advice would you give them? What questions should they be asking to understand the best approach, the best model for their particular situation?
I would start with the last thing you said, which is, what is your particular situation? And that will greatly reduce all of the thousands of models that I told you about. You start with what you're trying to do with the model. And then you start to look at what have other people done to answer the type of question that you're trying to answer with models. And then you focus on those techniques and those methods. So if you're trying to figure out, where is a fire likely to intersect a fuel break and how likely is it to spread over it or not. You immediately reduce the land use, and you immediately reduce certain, geographies because you're focusing on your geography. You immediately know, okay, I want to look at fire behavior because I need to know how something's going to spread. That said, you still may be in a world of complexity. But another thing is that a lot of times it's important to consider division of labor. If you are not a computer simulator, if you don't work with spatial maps, you collaborate with people who do. And that might sound hard, but there are a lot of people who do it. And there are a lot of agreements that can be made. And I'm an example of somebody who's done that. And, so if you have a simple question that you can answer with a simple model, that's great. But I think it comes down to fit for purpose. And also just respecting the fact that models are complex because fire is complex and there's no real easy way to make a model simple to answer a complex question.
So I realized within the first 10 minutes that this was not a 30-minute conversation. We could go on for hours talking about wildfire modeling, but
Yeah.
unfortunately time is not on our side. I've really enjoyed this conversation. Thank you so much for joining us and helping us to better understand how modeling can guide smarter decisions around wildfire resistance. And thanks to everyone listening to Neal on Fire. If you enjoy this conversation, be sure to subscribe, share it with colleagues, maybe who are trying to figure out wildfire risk, wildfire modeling. And you can now be the expert because you listened to Alexandra today. And please share it with other folks. And we will see you next time on Neal on Fire. Thanks again for joining us.
Thanks. Thank you.